Split muscle fiber. This video will show the low jitter in recordings from split muscle fibers. These values should not be included in calculation of mean MCD in a complete jitter study. In patients with dystrophy, a muscle fiber may be split in two or more branches. Each branch produces its own action potential. Although they start at the same end plate, the action potentials reach the recording electrode at different time. This occurs due to difference in the action potential propagation velocity among the branches. On sfemg recordings, they are clean single fiber spikes. One can measure jitter between these potentials. Because they have a common end plate, the jitter between them should be zero. In volitional sfemg, very low jitter value, usually 5 microseconds or less, is considered as recording from two branches of a split muscle fiber. Sometimes we see more than two branches, like in this schematic example of 6 branches. This recording contains 5 time-locked potentials. Some of them are branches from a split muscle fiber. We will trigger on the last potential that has the highest amplitude. Due to multiple time-locked potentials with low jitter, the sound of the signal is similar to a complex repetitive discharge. Note that a complex repetitive discharge occurs with the muscle at complete rest. These signals obtained here are volitional motor unit activity. One can also hear the change of the firing rate of the motor unit. Here the discharges are shown in superimposed fashion. The 5th potential appears constant on the screen as it was used for triggering. The 4th potential shows a good superimposition, but a slight jitter. On analysis, the jitter is 9 microseconds. This is low, but greater than the 5 microsecond cutoff used for split muscle fiber. There is a good correlation between the interpotential interval and the interdischarge interval, which indicates the effect of a velocity recovery function. The mean interpotential interval is quite long, 4075 microseconds. This combination may have exaggerated the jitter value, even though we're recording from two branches of a split muscle fiber. We will test another pair of potentials, number 3 and 4. This has a shorter interpotential interval, and that should reduce the effect of the velocity recovery function. The jitter is 4 microseconds. The interpotential interval changed minimally from one discharge to the next. It also shows a slight trend towards higher values near the end of the epoch. The 4 microseconds jitter is consistent with the split muscle fiber. Let us measure the jitter between potentials 1 and 2. They have low amplitude and a poor signal-to-noise ratio compared to the remaining potentials. The jitter here is 6 microseconds. It is just over the 5 microsecond limit. In view of the low amplitude, however, one may accept this as evidence of a split fiber also. Split muscle fibers are not a feature in recordings from patients with primary neuromuscular junction disease.